A conventional stabilizer bar is a solid one-piece bar made of spring steel, mounted to the vehicle chassis in bushings, with the ends of the bar connected to the suspension by solid links. When cornering, the suspension on one side of the vehicle is compressed, and the suspension on the opposite side is extended. The stabilizer bar twists in opposition to these forces and generates a torque at its mounting points to oppose the roll of the vehicle body. This helps control body roll during cornering, but adds to ride harshness when a bump is encountered by only one wheel, as the bar will resist suspension deflection. Forces from the bump will also be transmitted to the suspension on the opposite side of the vehicle. The larger the diameter of the stabilizer bar, the harder it will be to twist, and the more it will control body roll during cornering. However, the larger the bar, the greater the resistance to suspension deflection, and the higher the percentage of the deflection force that will be transmitted to the opposite wheel, resulting in reduced ride comfort. The size of the stabilizer used is normally a compromise between optimum body roll control and ride comfort. Active stabilizer bars eliminate the need for this compromise by decoupling the bar from the suspension, unless yaw rate and lateral acceleration sensors detect a roll or pitch of the entire vehicle structure. Active stabilizer bars are typically hydraulically controlled. They have a hydraulic pump that supplies pressurized hydraulic fluid to control valves. The stabilizer bar may be a split design with each side of the bar connected to opposite halves of a hydraulic oscillating motor. During straight-ahead driving, the two sides of the oscillating motor are hydraulically decoupled from each other, and the stabilizer bar halves are allowed to turn independently. When sensors detect body roll during cornering or evasive maneuvers, the control valves allow hydraulic fluid to flow through the oscillating motor in the proper direction. This flow of hydraulic fluid causes the two sides of the motor to turn in opposite directions, which twists the stabilizer bar pieces and transmits forces to the vehicle's suspension to resist the roll and keep the vehicle body level. Other systems use a hydraulic linear actuator to connect the two ends of a split stabilizer bar together. With no hydraulic fluid pressure and flow, the actuator is allowed to lengthen and shorten with no resistance as the ends of the bar are deflected. This effectively decouples the bar from the suspension. When body roll is detected, the control valve sends hydraulic pressure to one side of the actuator. This causes it to either lengthen or shorten and twist the bar ends in the correct direction to oppose the body roll and keep the vehicle level.